Hi everyone, I'm Shaja Sainu. I'm with AWS Cloud team. So today is a Terraform tutorial video with a real-time example. So let us move to Terraform and its use cases. So I will give you one resources. After that, I will give you one real-time example. So this is how my YouTube videos will work. So let us move back to Terraform. So Terraform is like a magic spell for computers. It helps people who work with computers, like engineers and developers. They'll create and manage all the things now, works with others. If you have friends who also want to build houses, Terraform helps everyone work together. It's like sharing the magic wand with others so they can build their houses too. Use a magic wand, Terraform. Terraform is like a magic wand. You tell it what you want. Say, for example, like a house with three bedrooms and a big garden. And it makes it happen in the computer world, right? Keep things in check. Now, imagine you want to change your house later, like adding a swimming pool. So, in simple terms, Terraform is like a magic tool that helps you plan, create, and change things in the computer world, like houses in real life, safely and easily. It's used by computer experts to make sure everything runs smoothly when they build software and websites. Welcome back everyone to our Terraform session. In this session, we are creating a resource from AWS, which is VPC. In that VPC, we are creating two subnets, one private subnet and one public subnet. For that, we need to give a route table. In this case, I'm going to give one route table for public subnet. For to access that resource, we need internet gateway. Let's see how we are making it. For that, I need to create one folder, which is VPC Terraform. Let's open that. To open command lines from this folder, we need to give CMD. So it will open CMD. From here, I need to call Visual Studio. For that, code dot. Let's open that. So finally, we have opened our Visual Studio from from VPC Terraform folder. In this folder, we need, so basically now our AWS console doesn't communicate with this Visual Studio. For that, we need to give a provider block. So in this provider block, I'll show you that provider block first, so you'll get a clarity. For that, AWS provider Terraform. So this is the company, HashiCorp. Let's open that. Here you can see use provider. So this is the provider block. Let's copy this and let's put it in Visual Studio. We will call this, we'll name this as provider.tf. So when you give .tf, it will automatically provide you the logo of Terraform. Okay, so provider.tf. Let's paste the code here. So it says Terraform required providers, AWS, that is our cloud, and the source is HashiCorp. Why HashiCorp means it is automatically going to the website and search for HashiCorp AWS, and the version will be 5.1.7.0. So this is our provider block. Now now it is connected to our Terraform. Now our Terraform doesn't know which account we are working for, right? So for that, we have to configure. The code will be like profile. I'll show you what exactly is this. Now we are saying to our AWS console that it is Shaja's AWS. Okay, and we want to create a region. Say for example, I'll give region. So US East 1. So this is the region for North Virginia. Okay, I'll show you that first. For that, we are logging back in. We need to create a console in this, and it is free only. So this is North Virginia region, right? And the code and the region code is US East 1. That is what we are referring here. Okay. So this we are set with our provider block. Now every time when you code something, you have to save it. For that, Control S. To open a new terminal from Visual Studio, we have shortkey, which is Control Shift Tilt Symbol. Will automatically give you the terminal. So our provider block is set up, right? So we need to initialize first. That is the first thing we need to do once you code something. For that, you have to give Terraform init. So basically, this init command will initialize all the packages for this provider block. So it'll take a couple of seconds, and I'll show something in VPC, my VPC. So what all VPC is there in the console? Let's see. It is taking them some time. So now it is there only default VPC, right? VPC is default. There is no VPC in my console. Okay. So I will create VPC from our Terraform. Terraform code is initialized successfully. So let us go to our AWS console. I will refresh the page. There is nothing in our VPC, right? So we will create one VPC from Terraform. For that, we will give a name main.tf.
So we have given main.tf as the file name. So let's go to Google and search for VPC Terraform resource. So in this documentation of HashiCorp, we will get all the code. Just copy there and paste it here. That's it. So, so this is the basic usage of this item block. We will copy this. So it says resource AWS VPC main. So the default name is main. We can change to main TF. Title block we can change to 24. Instance tenancy will be default. So why it is default, I'll show you. If we go to the console, you can see your VPC, create VPC, VPC only. So in this VPC console, we have only CIDR block, right? IPv4 CIDR block we have, tenancy we have, and tags we have. So that is what we have given here. In tags, I'll name it as TF for my reference. So it says it is not saved. This dot refers that it is not saved. So we have to save before executing the code. So before I execute Terraform apply and see the plan, Terraform plan. It will take a couple of seconds to complete that procedure. Let's wait for a while. So it says one is added, zero to change and zero to destroy. Now we will perform our main Terraform apply. When you apply this, it will go to the AWS console and says Shaja's AWS needs this resources, which is VPC resources. So it will ask you a value which is S. After you give that value, we can go to our AWS VPC and check if it is working or not. For that, go to your VPC. Now it says that main.tf, right? So whatever you perform here in this CIDR block, it will automatically refers to the console. Okay. Now VPC we have created. As you guys can see, our VPC is created with the CIDR block 24, right? Okay. Now we can create two subnets, one for public and one for private. Let's see how we are going to do that. For that, go to Google, type VPC subnet. So it will direct you to HashiCorp again. Now copy this resource code and paste it. Before I paste, let me give a name so that everybody can see. Subnet. So this resource block says that resource AWS subnet, right? So main.tf. So we need to refer this VPC for that. We in the resource which is this main.tf. When you type AWS, it automatically gives this option AWS VPC main.tf. Hit that and add .ip to refer that particular VPC. So our public subnet is set. We'll save it. Now we have to create one private subnet as well. For that, private copy this resource block. Just you have to edit the name. That's it. Inside the block of the private subnet. So that 10.0.0 128 slash 24. And I change this name. Save. So before saving that, so after saving the resource block, we have to perform two operations. One is Terraform public, Terraform plan, and Terraform apply. So we will give Terraform plan and check if there is any error. So it says two resources added, nothing to change and nothing to destroy. Right? So if you see here, you will get a clear picture. It says AWS update main drive. So it is creating private subnet. For that availability zone is checking, CIDR block is there checking. So this is what exactly happening in the backend. Okay. Now we will give Terraform apply. the value yes. So it is creating. Now it says apply completed. Let's go and check in our submit section. See, mail dot everything. Right. This is we have created. Let's just check if that is what. See, the second one is no. Because everything is S, right? That is the default subnet. Only two no subnet is there. And that is what we have created Lambda. So this is how you create VPC and two subnets. Now if you can see, if you go to the console, in the resource block on the left side, it says VPC, subnet, routable, internet gateway. So when you come to Terraform, this is not the right practice to follow. Before moving to routable, we need to create internet gateway. So that will be the best practice if you follow that way. For that, we'll go to info, search for internet gateway Terraform. So every time go to HashiCorp website. Right. So this is the example usage of internet gateway. Let's copy this. We'll give a name here. Paste it. I'll rename to IGW. Here we need to give our VPC name. So copy this. Yeah, let's name IGW. Let's save this. Let's create our table now, and we will associate after that. Go to switch to table. We will copy this. We need to change the route table name. For that, we'll copy our VPC ID and paste it here in the route table resource block. Now we have done that. We have to give internet gateway ID, right? So in the session, it says AWS Internet Gateway example.id. Instead of example, we have to give IGW. Why IGW is because we have given IGW as the reference. Now dot ID, right? So it says no error. Um, Now we can run Terraform plan and check if there is any error. Before that, I'll show my internet gateway if I have any internet gateway. Yes, one internet gateway is there, but it is already it's a default one, so it's already attached with the default VPC. So if you come here, it says two resource plan to be added, right? One route table and one internet gateway. We'll give Meanwhile, we will reload here. If that action is completed, we can see our internet gateway in the AWS console. It's completed. Let's go and check. Yeah, now you can see mean IGW, right? Yes. Now we have to create one route table association. So why one route table association is because we have one public route table. So yeah, our log is ready. Our VPC two subnet, which is one is private and one is in public, and one internet gateway we have added, and one route table for public. So we are done with our first part of our video, guys. So please support and share. Thank you.